Hello everyone, a very good evening to all. Myself Vivekananda Naik, I am a PhD research scholar in the Department of Energy Science and Engineering, IIT Delhi. So I welcome you all once again for this introduction session on solid state physics, which is being flowed this July 2024 session with course code NOC 24 PS43 by NPTEL. So today, this is a sixth introduction session, so we will cover a few concepts. We will cover a few problems that is based on the concepts taught in the week 6 of the course content that basically covers the electrical properties of matter, how the properties varies and how what laws, what are the laws and how the concepts we will be solving a few problems. So before solving those problems, if you are following the video lectures or videos of the interview session, then in the last interview session we are solving a few problems, and there are two more problems related to those calculation of reciprocal lattice parameters. So we will first solve those two problems, and then we will continue our so, discussion solving the problem that is based on electrical properties of matter. So the first question says two-dimensional lattice has the Bravais vector A vector is equals to 2 I cap, B vector is equals to I cap plus 2 j cap. Find the reciprocal lattice vectors. The options are option A vector, A star vector is pi by 2, 2i minus j, B star vector is pi j. Then there are four options. Option B says pi by 3 I minus 2j, 2 pi j. Option C is pi by 10 I minus j, B is pi by 2j. Option A is pi by 16 I plus j, B is pi by 3j. So these are the four options. So if you remember what we had discussed in the last session, so prior to this problem in the last introduction session, the last two problems are based on the same formula, and we had calculated a formula that is if a vector and b vector are given, then how we will calculate the reciprocal lattice vectors a star vector and b star vector. So those formulas were a star vector was 2 pi a vector cross b vector magnitude square, then b vector magnitude square into a minus a vector dot b vector to b vector, and then b star vector was 2 pi a vector cross b vector mod square a vector mod square into b minus a vector into b vector into a vector. So you just need to simply replace a with b and b with a. So since this is magnitude, so it will again remain same. So here in case of a star vector, it was b mod square a. Here it is a mod square b, and here it was a dot b into b. Here it was b dot a into a. So a dot b, b dot a both are equal since it's a dot product. So these will be the two formulas. Now if you put the values, then you can calculate. So I'll give a few minutes to try this question, and then I will discuss how what will be the correct answer. So did you solve it? So if you calculate, it will be A star will be 2 pi divided by A cross B vector. A cross B vector mod will be 4, so it will be 4 square. Then A mod square into B will be 10 I cap minus 2 J cap plus 4, 2 I cap plus 4 J cap. So it will be 2 pi by 16, 8 I cap minus 4 J cap, or it will be pi by 2, 2 I cap minus J cap. So this will be A star vector, and then similarly B star vector will be 2 pi by 16, 4 I cap plus 8 J cap minus 4 I cap. So it will be 2 pi by 16 into 8 J cap, that is pi J cap. So these are the expression for A star vector and B star vector. So the correct option is option A. So A star vector will be pi by 2, 2 I cap minus J cap, and B star vector will be pi J cap. Then the next question, the question says, find out reciprocal lattice vectors for a space lattice defined by the following primitive translational vectors. A vector 5 I cap plus 5 J cap minus 5 K cap. B vector minus 5 I cap plus 5 J cap plus 5 K cap. C vector is 5 I cap minus 5 J cap plus 5 K cap, where I cap, J cap, and K cap are unit vectors along the X, Y, and Z axis respectively. So these are the four options. The we need to find out what will be the correct option. So again, this is the same question, but however, we can't use the previous question's formula, because here in this question we have A, B, and C. So since it is A, B, and C, and we know in order to calculate the lattice, the reciprocal lattice vectors, the formula is A star vector is equals to 2 pi B vector cross C vector divided by A vector cross B vector dot C vector. V star vector is 2 pi C vector cross A vector divided by A vector cross B vector dot C vector. Then C star vector is 2 pi A vector cross B vector divided by A vector cross B vector dot C vectors. So these are the formula for calculating the reciprocal lattice vectors. So if you use those formulas and put the values of A vector, B vector, and C vector, you can easily calculate what will be the correct answer. So please calculate and tell me. Uh, Also, there is another trick to solve this type of question. I will definitely tell you. But first, you just calculate what will be the correct option out of these four options.
Is it option yes, sir?
Yes, so option A is the correct option. So did you calculated the
Yes,
calculated using all these three formulas?
I calculated, sir.
So, but if you see these vectors that are given, A vector, B vector, and C vector, they are in some particular order. So if you see the A vector is, if you take since all these vectors, 5 can be taken out as common. So if you see, it will be 5 taken out as common, then I cap plus j cap minus k cap, j cap plus k cap minus I cap, and C vector is I cap plus k cap minus j cap. So basically, this is a form of BCC lattice, that is body center cubic lattice. So if you are if you are followed the lectures, then the reciprocal of BCC lattice is an FCC lattice. So, and the FCC lattice vectors at the unit cell of the FCC lattice has of the form I cap plus j cap, j cap plus k cap, and C vector is I cap plus k cap. So, obviously, the option A will be the correct option. Did you get it?
Once again, explain, sir. How is it taken a
Basically, if you
BCC and FCC?
so basically, generally, in case of calculating some basic conversion like is from direct lattice to reciprocal lattice, if you see, there are some formulas like there are some simple cubic lattice whose reciprocal is again simple cubic, and in case of body centered
Yeah,
cubic lattice, the reciprocal of body centered
FCC,
cubic is face centered cubic, and the reciprocal of face centered cubic is body centered cubic.
BCC.
So
Oh, yes,
here
sir.
the vectors that are given, these are of the form of body centered cubic form. So this is I cap plus j cap minus k cap minus I cap plus j cap plus k cap, I cap minus j cap plus k cap. It is in the form of BCC lattice. So since we know that the reciprocal of BCC is FCC, and FCC has the form I cap plus j cap plus k cap, and I cap plus k cap, and all other options they have different coefficients. You see here, uh, one more thing also in option D also it is also I cap plus j cap plus k cap, I cap plus j cap, but here it is pi by 5. So here this will not be correct option. So anyway, you can calculate it in that way. However, you can directly say if 5 taken as common, so it will be pi by 5, and the form will be of I cap plus j cap plus k cap, and I cap plus a cap. Then we will continue our discussion. So now we will solve a few problems that are based on the concept of electrical properties of matter covered in this week's lecture. So the first question says, calculate the conductivity of copper at room temperature. The collision time tau for electron scattering is 2 into 10 to the power minus 14 second at this temperature. Consider free electron density in copper is 8.5 into 10 to the power 28 per meter cube. So here we need to calculate the conductivity of copper. The collision time tau for electron scattering is 2 into 10 to the power minus 14 second. The free electron density in copper is 8.5 into 10 to the power 28 meter cube. So this is the number density. This is the collision time for electron scattering. And using these two values, we need to find out what will be the conductivity of copper. These are the four options: 2.16 into 10 to the power 8, 4.78 into 10 to the power 7, 5.65 into 10 to the power 6, and 3.23 into 10 to the power 5. So these are the four options. I'll give a few minutes for you to try this question, and then I will discuss.
Explain this one, sir.
Okay, so if you see here, we need to find out the conductivity of copper. So are you following the lectures of the course?
Actually, this week I didn't listen this week lecture.
Okay, so uh, so I will definitely request you to follow the lectures, but
Okay, okay.
simply we can
Rest of it
calculate the
now.
formula. So simply we can calculate the formula for conductivity. So you know the electric field and the current density is given by the formula J is equals to sigma E. This is another form of Ohm's law where this sigma is the
Conductivity.
conductivity. Again, this current density J can be represented as J vector is equal to NeV vector, where N is the number density of electrons, E is the charge of electron, and V is the generally V is the drift velocity. So whenever there is a field, then there will be drift of the electron because electron will follow the electric field and then correspond to the electric field. When the electric field is applied, then there is drift motion of the electrons, and due to this motion, we can calculate the current density, which will be in the form of NeV. And if you calculate the drift velocity, then this drift velocity is given by E tau E by m, where m is the mass of electron, E is again the charge of electron. This tau which is given in the question is collision time tau for electron scattering, or otherwise this tau is called as relaxation time, and it is again defined as the time taken for the drift velocity to be 1 by E times of the initial velocity. That is, whenever there is a field present, the electron will obey the drift motion, and whenever the field is removed, how much time does it take for that drift velocity to reduce to be 1 by E times of its initial velocity. So this tau is the relaxation time, and E is again the electric field applied, and E is the charge of electron. Now if you see, if you equate all these relations, so what we can write, J is equals to NeV, so NeV is equals to sigma E. Again, Ne into E, V is E tau E by M, E tau capital E by M is equals to sigma E. So E gets cancelled out, and we can say sigma is equals to N E square tau by M. So this is basically the numerical formula for calculating the conductivity of that metal, where N is the number density, that is the number of electrons. Here in the question, the free electron density in copper is 8.5 × 10⁻28 per meter cube. So this is the number density of electrons, and E is the charge of electrons. Tau is again the relaxation time, and M is the mass of electrons. So this is the required formula to calculate the conductivity, and simply, and again, similarly, if you want to calculate the resistivity, we know resistivity is reciprocal to conductivity. So the resistivity, which is rho, that is 1 by sigma, will be so this resistivity rho is 1 by sigma, that is m by n e square tau. So in the question, the known values are, we are given with the values, that is tau. Tau is 2 into 10 to the power minus 14 second. Then n, that is the number density of electron, is 8.5 into 10 to the power 28 per meter cube. 8.5 into 10 to the power 28 per meter cube. Then E we know 1.6 into 10 to the power minus 19 coulomb, And the mass of electron again we know 9.1 into 10 to the power minus 31 kg. So if you put all these values in the equation, sigma is n is square tau by m, then you can calculate the conductivity. So please put these values and tell me what will be the correct option. Basically, these concepts are based on classical free electron theory of metals, and all these treatments are of classical theory. We are in the upcoming time we will be discussing problems that will be based on quantum theory, that is Fermi gas model. But here it is classical free electron theory. There are some assumptions also, and this model is also known as Drude model.
4.782 into 10 power 7.
Yes, the correct, so if you put the values, then it will be 4.78 into 10 to the power 7 ohm inverse meter inverse, because we know the unit of resistivity is ohm into meter, which can otherwise written as RA by L. This is another formula of resistivity. So since conductivity is the inverse of resistivity, so it will be ohm inverse meter inverse. These are the unit is ohm inverse meter inverse. So this is the correct answer, and the correct option is option B. Is this clear to you?
Yes, sir.
So we will move to the next question. Question number two. The question number two says the resistance of a sample of copper wire of 0.05 mm radius and 0.2 meter long is 0.439 ohm. Then calculate its resistivity. Is one options are 1.72 into 10 to the power minus 8 ohm into meter. Option B 1.52 into 10 to the power minus 8. Option C 1.42 into 10 to the power minus 8, and option D 1.22 into 10 to the power minus 8. These are the four options. Calculate and tell what will be the correct option.
Sir, is it 1.72 into 10 power minus 8 ohm meter?
Yes. So the correct option is option A, 1.72 into 10 to the power minus 8 ohm into meter. So I just mentioned the formula for resistivity is RA by L. And if you see, there are different formulas. Like if you see, the one expression is M by N square tau, and the other expression is RA by L. But if you see here, which formula we will use to calculate? We will use the formula rho is equals to
RA by.
R A by L, because we have been provided with all this information, because we know the radius of the copper wire, the length, and the resistance. So R, we know R is 0.439 ohm, radius. So since radius is known, then the area we can calculate. The cross section area is here, basically the cross sectional area. So the cross sectional area will be, so radius small r is 0.05 mm. It will be 5 into 10 to the power minus 5 meter. Then cross sectional area A will be pi r square. It is 3.142 into 5 into 10 to the power minus 5 square. Then the length is also given. Length is 0.2 meters. So if you calculate, rho will be R A by L. That is 0.439 into pi into 0.05 into 10 to the power minus 3 divided by 0.2. So if you calculate it, it will give you 1.72 into 10 to the power minus 8 ohm into meter. So the resistivity of the copper wire is 1.72 into 10 to the power minus 8 ohm into meter. The correct option is option A, 1.72 into 10 to the power minus 8 ohm into meter. Then question number 3, the question says the resistivity of silver atom at room temperature is 1.6 into 10 to the power minus 8 ohm into meter. Calculate the collision time of electron scattering. Consider atomic weight of silver is 107.868 gram per mole. Density of silver is 10.49 into 10 to the power 3 kg per meter cube. And for silver atom, only one electron contribute to the conduction. That is, only one conduction electron take part in the electrical conductivity. So the number density of silver atom will be again equal to the number density of electron, because we are considering only one electron per silver atom. So we were options are option A 2.7 into 10 to the power 17 second, option B 1.7 into 10 to the power minus 16 second, option C 3.8 into 10 to the power minus 14 second, and option D 1.9 into 10 to the power minus 13 seconds. So again, you can identify which formula we will be using here in order to calculate the value of collision time for electron scattering. So please try. I will give a few minutes and then I will discuss what will be the correct answer.
So for this, can we take the formula tau is equal to m by n e square rho?
Yes, because if you see, you know the resistivity, you know the value of, and in order to find out the number density, we will use the atomic weight of silver and the density of silver atom.
Yes, sir. Can you explain, sir?
Mm, Try, you can do it because it is pretty simple. If you remember, we are calculating the density of atoms in case of crystal structure. We are using a formula. Na? If there is the atomic weight is given in gram per mole, and we need to find out the density. So we were doing same type of formula we will use here.
There A is given, A formula, na? Atomic lattice parameter.
Sorry?
So using lattice parameter, we have one formula, but that is additional.
No, no. Yes, yes.
Number density.
There is a formula na, regarding calculation of the density of atoms. If it has a FCC structure or BCC structure, we are putting n equal to 4 here, n equal to 2 for BCC, n equal to 4 for
Yes,
FCC.
sir. Yeah.
So the same formula we will be putting here, but here n will be the number density, and here, and in that case it was number of atoms per unit cell, but here we are talking about the whole sample, which is the atomic weight, that is 107.868. Just tell me, here it is given the atomic weight of silver is 107.868 gram per mole. Gram per mole means 1 mole is how many number of silver atoms? 1 mole means Avogadro's number of silver atoms. And Avogadro's number Na is, what is the value of Avogadro's number?
6.23 into 10 power 23.
Yes, 6.023 into 10 to the power 23 atoms per mole. So 6.023 into 10 to the power 23 atoms per mole. The weight of those atoms is 1.7 in 1.7.868 grams. So if you need to find out the number of atoms or the number of electrons, also here the density of silver is given. So what will be the number of atoms, silver atoms? So the number of silver atoms will be N equals to the density of silver atom, that is the mass density. Mass density you can say as D into Avogadro's number Na divided by mass of silver, that is Ma. Got it? Because again this density, the what is the unit of this density? This is kg per meter cube. Na is per mole, and here it is kg or gram per mole. So per mole gets cancelled out. This kg and kg gets cancelled out. This kg and this kg will get cancelled out. So the whole system or the whole expression has the unit of 1 by meter cube, that is number of atoms per meter cube, which is nothing but the number density. You got it?
Yes, sir.
So if you calculate the number density N will be 10.49 into 10 to the power 3 into Avogadro's number is 6.023 into 10 to the power 23 divided by the mass is 107.868 grams. So if you convert it into kilogram, it will be again 10 to the power minus 3 will be multiplied. So it will be 0.107868. So if you calculate it, you will get 5.857 into 10 to the power 28 atoms per meter cube. So since this value was in kilogram, so we converted this value from gram to kg. So the number density of silver atom is 5.857 into 10 to the power 28 atoms per meter cube. And since in the question it is given, consider per silver atom contribute one conduction electron. So the number of silver atom is again equal to the number of electron or the electron number density. So if you use the formula, rho is equals to m by n e square tau. Now you can put the values and tell me what will be the value of resistivity, or sorry, what will be the value of the relaxation time or the
Here,
collision.
sir, here we take M is the mass of silver atom. M.
Sorry.
Here we consider M is the mass of electron.
Yes, yes. Here we will consider the mass of electron because here we are calculating the conductivity. And in case of conductivity, the formula, this M is mass of electron, not the mass of the material. This is the mass of electron because the conduction, basically, if you see in case of solids, and on the basis of their electrical properties, they are divided into different types, that is conductor, semiconductor, insulator, and in all these type of solids, only one species that is responsible for electrical conductivity is electron. There's no one else which will conduct electricity. However, in case of thermal conductivity, you can say electron can play a role, and also the lattice. There is a term called phonon. You must have heard of it. They also plays role.
Yes.
That is, there are lattice vibrations also plays role, and also electron also carry thermal conductivity. Electron also carry heat, and they contribute to thermal conductivity. But in case of electrical conductivity, there are no other agents to carry electrical signal. That is only electron. So here the mass will be only mass of electron. So in case of the in this formula, this m is mass of electron, n square tau. So tau will be m divided by n square rho, and we we have all the unknown, we have only one unknown value, that is tau, and all these are known to us. So ME is again 9.1 into 10 to the power minus 31 kg. E is 1.6 into 10 to the power minus 19 coulomb. Then the number density N we just calculated. It is 5.857. 5.857 into 10 to the power 28 per meter cube. So if you put, there is another row. So rho is again given in the question. It is 1.6 into 10 to the power minus 8. 1.6 into 10 to the power minus 8 ohm into meter. So if you put the value, what will be the value of tau?
Is it 0.379 in 10 power minus 30?
Sorry, once again.
0.379 into 10 power minus 13.
Okay, so if you see the options, these are the four options, then which of those options will be correct?
3.8 into 10 power minus 14. C.
Yes, so the option C will be the correct option. So the value will be 3.8 or 3.79 that you are saying. 3.79 into 10 to the power minus 14 second, or
14.
you can write it at 3.8 into 10 to the power minus 14 seconds. So is this clear to you now?
Yes, sir.
So first we need to calculate. So this is the formula. In order to calculate the value of tau, we need mass of electron, the number density, charge of electron, resistivity. Resistivity is given to us. E we know. Mass of electron is again known. But we need to find out the value of number density of electron in a particular metal. In order to find the number density of electron, we need to find out the number density of atoms, or the density of atoms. And we know the mass of atom, we know the mass density, we know. So the mass of 1 mole of silver atom is given to us, and 1 mole contains 6.023 in 10 to the 23, basically 1 Avogadro's number of atoms. So if you put this formula, we can easily calculate the mass of, or the number of atoms per one per meter cube is 5.857 in 20 by 28. So in the question also it is mentioned, in consider only one atom for silver contribute to electrical conduction, but in the question if it was given that two electrons contribute, then we can multiply 2 here, so that we will be getting the number density of electron. So again, the relaxation time will be half. Got it? So if there are, in the question it was mentioned for silver atom contribute to conduction electron, then the number density of electron will be twice the number density of silver atoms. So in the value we will put n is equals to in place of 5.857, we will put 2 into 5.857. Now is this clear to you?
Yes, sir.
Okay, so we will move to the next question. The question says the resistivity of aluminum at room temperature is 2.62 into 10 to the power minus 8 ohm into meter. Calculate incremental velocity acquired by the free electrons in a electric field gradient of 100 volt per meter. Consider atomic weight of aluminum is 26.98 gram per mole. Density of aluminum is 2.7 into 10 to the power 3 kg per meter cube. And for aluminum atom contribute one free electron. So again, this question is pretty much similar to the previous question, but here we need to find out the incremental velocity acquired by the free electron in an electric field gradient of 100 volt per meter. So when there is electric field, then what type of motion of electron will occur?
Electric field.
In the presence of electric field or field gradient, there will be occurrence of, or the electron will show drift motion. And in case of
Drift.
concentration gradient, there is diffusion.
But here in the presence of drift velocity, sir.
Yes. So here in the question we need to calculate the drift velocity of electron. Basically here
Okay.
incremental velocity acquired by the free electron in an electric field gradient is basically the drift velocity of electron. This is the value of electric field. This is given to us. So in the first question we discussed the formulas how we will calculate the drift velocity. You can put those formulas and tell me what will be the value of the drift velocity of electron when it is placed in an electric field gradient of 100 volt per meter.
Is it 0.39 meters per second, sir?
Yes, the correct option will be option C, that is 0.39 meter per second. So here first we need to calculate the number density of electrons in this amount of aluminum. So similarly to the previous question, the number density will be the mass density rho, sorry, we can use rho here because we are already using resistivity as rho. So we can write here again D, then this is Avogadro's number divided by mass. It will be 2.7 into 10 to the power 3 into 6.023 into 10 to the power 23 divided by 26.98 into 10 to the power minus 3. Because here it is 26.98 gram. In order to convert it into kilogram, we will multiply minus 3 here. So if you calculate, it will give you 6.027 into 10 to the power 28 per meter cube. Then we know J is equals to sigma E and NEV equals to J. So NEVD equals to sigma E or E by rho. Is not it? Because here the resistivity is given, so we need to convert conductivity into resistivity. So NEVD is equals to E by rho. So VD is E by rho NE. Then if you put the values, then E is directly given. The value of E we have, it is 100 volt per meter. E is given 1.6 into 10 to the power minus 19 coulomb, and then resistivity rho is 2.62 into 10 to the power minus 8 ohm into meter. So if you put those values, VD will be 100 divided by 2.62 into 10 to the power minus 8 into 6.027 into 10 to the power 28 into 1.6 into 10 to the power minus 19. It will give you 0.39 meter per second. So this is the beat velocity of electron. So the correct option is option C. So now this is clear to you.
Yes, sir.
Okay, so we'll move to the next question. The question says, calculate the percentage increase in resistivity of copper on heating from 300 Kelvin to 500 Kelvin. The temperature coefficient of resistivity of copper is given by alpha equals to 0.0043 per Kelvin or Kelvin inverse. Consider linear increasing resistivity with the temperature due to only phonon scattering. So, as I was just saying, here we are talking about the percentage increase in resistivity of copper on heating. So, when we are heating the system, then there is due to phonon scattering, there is some contribution, and due to this contribution, the temperature coefficient of resistivity of copper is given by alpha, which is 0.0043. So now we need to calculate the percentage increase in resistivity of copper, that is the resistivity of copper at 300 minus the resistivity copper at 500 divided by the resistivity of copper at 300 into 100. This is the percentage increase in the resistivity of copper. So since resistivity increasing, so it will be 5 rho 500 minus rho 300 divided by rho 300. So calculate and tell me how what will be the percentage increase.
Sir, I'm not getting.
Basically, there is a formula for temperature coefficient of resistivity, that is alpha. So also we need to consider here there is linear increasing of resistivity with temperature. So there are two values. Suppose there are two values. One is R0, which is the resistivity as at 0 Kelvin. And there is another value rho T, which is the resistivity at T Kelvin. Then if you, according to the formula, the concept of temperature coefficient of resistivity, rho T can be given as rho 0, 1 plus alpha T, where this T is T minus T0, where T minus T0, suppose this is T0 Kelvin or this is T Kelvin. So this T is the difference in temperature and this is alpha. So this is the formula. So you can use this formula to calculate the value of alpha. So if you uh, rearrange this equation, it will be RT, it will be R0 plus alpha R0T, that implies alpha is equal to RT minus R0 by R0 into T. So here alpha we know, T also we know, T is T1 minus T2, or you can say T minus T0, or here in our case it is 500 minus 300, right? This is in Kelvin. So T is in Kelvin. And if you see, again the percentage change in resistivity is nothing but this value, that is RT minus R0. So percentage increase is nothing but RT minus R0 by R0 into 100. So T we know, alpha we know, we just need to find out this value. And if you multiply 100, it will be the change in or percentage change of the value of resistivity with temperature. So here in the question, one more thing is given. It is given that consider linear increasing in resistivity, but if you consider, but since it is linear, we are considering R0 into T. But if it is not linear, then suppose it varies at the square of temperature, then the formula will be RT equals to R0 1 plus alpha T square. Or if it varies as Q, then it will be alpha TQ, like that. So since it is in the question, it is given consider linear increasing, then we are multiplying alpha into T to the power 1 only. That is, there is a linear variation. And if you plot the graph, where T equals to, suppose this is the graph, this is the resistive R and this is T. So at T equal to 0, this is at 0, this value is at 0, and then with T it increases linearly. But if there is quadratic variation, then it will increase like that. So this is linear, this is quadratic. So please calculate and tell me what will be the percentage change in the resistivity.
%86.
Yes, so the change in resistivity will be 86%. So if you use the formula, so in order to find out the percentage increase, so we need to find out rho 500 minus rho 300 divided by rho 300. into 100 will be equals to alpha delta T into 100. Alpha, we know alpha is 0.0043. So change is delta T is 300 minus 500 mod into 100%. It is 0.0043 into 200 into percentage. So into 100 percentage. So it will be 0.86 into 100, that is 86%. So the percentage increase in resistivity of copper when we heat it to 300 Kelvin to 500 Kelvin, the resistivity is increasing. That's why the value is plus 86. So can you tell me, since here we are considering copper is a conductor or an insulator?
Conductor.
Conductor. So since copper is a
Uh,
conductor, so it has sufficient free electrons to carry the electric charge. That's why it has good electrical conductivity. But why at higher temperature its conductivity is reducing? As you can see, it's if you vary the temperature or if you increase the temperature of copper from 300 Kelvin to 500 Kelvin, you see within this 200 Kelvin variation, the resistivity is increasing by 86%. But can you say why the resistivity is increasing with temperature?
so because
Because
the
yes,
the the conductor will change into the insulator
no, why?
at high temperature.
No. Conductor, this is not correct. What happens at height when you start increasing the temperature of the conductor? What happens? Now you see there was another formula for resistivity. You must remember this was the formula where it was the formula m e square equals to sorry rho is equals to m by n square tau, is not it? So the formula was rho equals to m by n square tau. So can you tell me when we increase the temperature from 300 Kelvin to 500 Kelvin, which of the parameters get affected? Will the mass
Number
of
density.
electron change?
No, mass of
No,
electrons
how
same.
the number density will be affected? Sorry, mass of the electron will not change. Charge of electron is again a constant, it will not change. Also, the electrons are flowing inside that matter. They are not being lost anywhere. So the number density again will be same. Why the number density will change? It will not change. Understood?
Sorry, sir. Sorry. Number density.
You were saying that the number density will change, but why the number density will change as we go on increasing the temperature?
So their number of electrons released from the conductor, no? When the temperature increases.
No, number of electron will not change. Only change will be this tau, that is the relaxation time. Otherwise, we can call this tau as the collision time for electron scattering. Whenever you start increasing the temperature, since there are a lot of electrons, so they will collide more frequently. So since their collision frequency will increase. Also, the collision frequency, since the collision frequency is increasing, this relaxation time will decrease, is not it?
Yeah.
Before the electron was colliding once in 10 seconds, but since we are increasing temperature, it is getting more energy. So due to this gain in energy, it is vibrating more rapidly as compared to the 300. So it will undergo more collisions. That's why the relaxation time. So suppose there were two collisions in 10 seconds, but now there are 8 collisions in 10 seconds. So the relaxation time between two collisions is decreased because the electron is colliding more frequently. That's why this tau is decreased, and since this resistance varies inversely as tau, so as tau decreases, the resistivity increases. So with increasing temperature for metal only, sorry, for conductor only, the temperature, sorry, with increasing temperature, the resistivity increases or the conductivity decreases. You got it? But
Yes,
it
sir.
is exactly opposite for semiconductors. In case of semiconductors, they have a very few electrons. But as we go and increase the temperature, there will be more electrons that will be coming out of the valence band to conduction band in order to conduct electricity. That's why for semiconductor, they have negative coefficient of resistance, negative temperature coefficient of resistance. That is, as we increase temperature, their resistance decreases. But in case of conductor, as we increase temperature, their resistance increases. You got it?
Yes, yes.
So the behavior of conductor and semiconductor are different in terms of electrical conductivity when there is temperature variation. So
That means
question number 6.
when temperature increases in the conductors, no electrons are released from the conduction band, the valence band. Yes, sir?
No, you see, in case of conductor, there is no band gap, na. The valence band
Yeah.
and conduction band overlap with each other. So all electrons that are present in the in the valence band, they are also present in the conduction band. So
Yes.
maximum number of electrons are available for conduction. So due to
Yes.
increase in the temperature, those electrons that were available for conduction, they will collide more frequently with each other. So then there will be loss. So at suppose at a particular cross section, their velocity was suppose x before collision. Now, since they are colliding more frequently, their velocity or the drift velocity will again decrease. So due to this decrease, their conductivity is decreased. That's why the resistivity is increased. Now you got it?
Okay, sir. Yes, I got it.
You can very simply take one example. Suppose there is a room, there are 5 students in it, and there is a small door, and you ask those students to move out of the room through this door. So they will easily move because there are only 5 number of students. But now, if you increase the number of students into 50, so while they move towards the door, they will collide with each other more frequently, is not it? So after a certain
Yes,
time,
sir.
a very few of them will be able to pass the road or pass the room and to exit through the window. So it's same thing
Yes.
happens if you take a cross section for a conductor. Since there will be more collisions as the electron travels, so lesser number of electrons will be passing through a particular cross section as compared to the previous case when there was fewer collisions. So they were passing easily. But in case of semiconductor, what happens? Since there are very less number of electrons, if you increase the temperature, the electrons that are present in the valence band, they will again come to the conduction band by gaining those energies, and that's why they will conduct. They will help in conduction of electricity, and the conductivity will increase and resistivity will decrease. But in case of metal, the resistivity increases and conductivity decreases as we increase the temperature. That's why here it was plus 86. That is, the value of resistivity as 500 is
Yes.
greater than the value of resistivity at 300. Is that clear to you now?
Yes, sir.
Okay, so question number 6: the acceleration in meter per second square of a free electron in an electric field gradient of 200 volt per meter is. The option A 3.50 into 10 to the power 13, option B 1.76 into 10 to the power 3, option C 1.76 into 10 to the power 13, and option D 3.3 into 10 to the power 32 meter per second. So this is very simple question. You don't need any other concepts to solve this question. This is pretty straightforward. What will be the acceleration of a free electron if the electric field gradient is 200 volt per meter? That's it. This is the question.
Is it 3.5 into 10 power 13, sir?
Yes, the correct option is option A, that is 3.5 into 10 to the 13. So this is pretty simple. If you calculate, we know the force experienced by a charged particle in electric field is given by F is equals to E or QE, where Q is the charge and E is the electric field. So again, this force, we know force is mass into acceleration. So suppose this is electron, then it will be mass of electron into acceleration equals to E into the electric field. So this the Q will be, A will be E by ME. It is 1.6 into 10 to the power minus 19 into E is 200 divided by 9.1 into 10 to the power minus 31. If you calculate it, the acceleration will be 3.5 into 10 to the power 13 meter per second square. So the correct option is option A, 3.5 into 10 to the power 13 meter per second square. Then we'll move to the next question. The question says, a wire whose length is 1 meter and diameter is 1 meter just must carry a 20 ampere current in an application. The maximum power dissipation along the wire
Repeat,
is
not visible, sir.
5 watt.
Okay.
Now it is visible.
Yes.
Thank you. So a wire whose length is 1 meter and diameter is 1 millimeter must carry a 20 ampere current in an application. So we need a certain wire for an application where it is intended that this wire will carry 20 ampere of current. The maximum power dissipation along the wire is 5 watt. So due to carrying this electron or due to carrying this current, there will be some power dissipation. This power dissipation is 5 watt. Then calculate the minimum permissible conductivity of the wire for this application. So what wire should we choose so that the so there is conductivity of different wires. So what should be the minimum permissible conductivity of the wire for this application? So what should be the minimum conductivity so that it can carry a current of 20 ampere and it will dissipate maximum of power of 5 watt. So you can calculate and tell me what will be the minimum conductivity of the wire for this intended application. Are you being able to calculate?
Sir, I get it. The formula of power P is equal to I square rho L by A. Can you take based on that one?
Yes.
I'm doing conductivity 1 by rho.
See, here there are two concepts. One is maximum power dissipation along the wire is 5 watt, and then for that particular application, the length is 1 meter, diameter is 1 meter, and it must carry 20 ampere current. So since the length and diameter is given, if we know the resistance, we can calculate the resistivity, and then from that resistivity, we can calculate conductivity. Is not it?
Yes.
So for calculating conductivity, we need to first calculate the resistivity. Resistivity is Ra by L, is not it? And
Is it 10.2 into 10 power 7?
yes, the correct option answer is 10.2 into 10 to the power 7 ohm inverse meter inverse.
Meter inverse. Okay.
Yes. So the expression for resistivity is rho equals to Ra by L, and the conductivity is inverse of resistivity, that is 1 by rho. So again, the maximum power dissipation, if I be the current and R be the resistance, then the maximum power dissipation is I square R, which is power dissipation P. This is given 5 watts. So I square R is equals to 5. So R will be 5 by I square, that is 5 by 400, because I is equals to 20 ampere. So since R is now known, we can easily calculate rho, because rho is Ra by L. So rho is Ra by L, that is 5 by 400 into A is pi R square, will be pi into R square. Here diameter is 1 mm, so uh, radius will be 0.5 mm. So 0.5 into 10 to the power minus 3. 0.5 into 10 to the power minus 3 square divided by L. L is 1 meter, so 1 meter. If you calculate, it will give you resistivity. So again, conductivity is 1 by resistivity, so it will be 400 divided by 5 into pi into 10 to the power minus 6 into 4 in the numerator, because it will be 1 by 2 square, it will be 1 by 4. So 4 is the numerator. So it will be 10.2 into 10 to the power 7 ohm inverse meter inverse. So this is the, so it is 10.2 into 10 to the power 7 ohm inverse meter inverse. Is it clear to you?
Yes, sir.
Okay, so now we move to the next question. The question says the collision time for reluctance scattering in copper is 2 into 10 to the power minus 9 second at 4 Kelvin. Calculate the conductivity of copper at 4 Kelvin. Consider the free electron density of copper at 4 Kelvin is 8.5 into 10 to the power 28 per meter cube. So we need to find out the free electron density of copper. Sorry, consider the free. So we need to find out the conductivity of copper at 4 Kelvin, where the free electron density of copper is given and the collision time for electron scattering of copper is given. So this question is again pretty much similar to the previous questions that we had solved. So the conductivity will be N square tau by M. N is known to us. It is 8.5 into 10 to the power 28 per meter cube. E we know, M we know, and tau is given. It is 2 into 10 to the power minus 9 second. So the value of conductivity can be calculated. So please put those values and tell me what will be the correct option.
4.78 into 10 power 12 ohm inverse meter inverse.
Yes, it is 4.78 into 10 to the power 12 ohm inverse meter inverse. 4.78 into 10 to the power 12 ohm inverse meter inverse. And question number 9. Calculate the de Broglie wavelength of an electron that falls through a potential of 600 volt. Consider the Planck's constant. Age is 6.6 in 10 to the minus 34 joule into second. So again, the options are option A 0.5 Armstrong, option B 0.6 Armstrong, option C 0.7 Armstrong, and option D 0.8 Armstrong. So can you tell me how we will calculate the de Broglie wavelength if it the electron falls through a potential of 600 volt?
This is 0.5 angstrom in it.
Yes. So how did you calculate?
Actually, I consider the formula lambda is equal to h by mv. Otherwise,
Yes.
the formula, another formula, lambda is equal to h by lambda equal 12.24 angstrom units by square root of v. V means
Yes.
potential.
Yes.
Yeah.
So how this formula has been derived?
Uh,
You said na lambda in Armstrong will be 12.24 divided by root v. So how this formula is derived?
Sorry, sir.
How this formula is derived? How lambda lambda if v is given, then you just said na lambda will be 12.24 Armstrong divided by root v.
I
Is it?
consider the kinetic energy
Yes.
of
So
mv
how did
square is
you?
equal to applied potential. Kinetic energy, the applied is equal to applied
Yes.
potential
So
energy. Of mv square is equal to ev.
yes. So when an electron passes through a potential v, then the energy gained by electron can be equated as half mv square is equals to E into V, where V is the potential. So mv square is 2EV, or if you multiply m on both sides, it will be mv square 2ME. Sorry,
ev.
this is not small b, this is capital V.
Yeah.
Then this is P square is 2ME capital V. So P is root over of 2ME capital V. And we know lambda is equals to H by P.
H by
So H by 2ME V root over. So since H is constant, M is constant, E is constant. So if you put all these, you will get 12.24 by root V in Armstrong. So if you put those values, you can calculate it lambda to be 0.5 Armstrong. So the correct option will be option A, 0.5 Armstrong. So I don't think there will be any doubts in the previous question. So let's move to the next question. Question says, what should be the energy of What should be the energy of the quantum state, which has 18 for the sum of the squares of the quantum numbers n, x, ny, and nz. Assume the solid to be 1 centimeter into 1 centimeter into 1 centimeter dimension. Consider Planck's constant h equals to 6.6 into 10 to the power minus 34 joule into second. So now we are considering here the quantum theory, that is what will be the energy of the quantum state which has the sum of squares of the quantum number, that is nx square plus ny square plus nz square equals to 18. Then what will be the energy corresponding to those values? The options are option A 2.15 into 10 to the power minus 32 joules, option B 1.07 into 10 to the power minus 32 joule, option C 1.15 into 10 to the power minus 33 joule, or option D 3.32 into 10 to the power minus 33 joule. So can you tell me what is the expression for energy of the free electron in a three-dimensional box?
See here, E is equal to h squared by 8m into n square x plus n square y plus n square z by dimension. A
Yes, so
square.
we
This is
will
a
use
cubic
that
size.
too. Exactly the same formula we'll use here. And here nx square plus ny square plus nz square is given to you. So then it is pretty straightforward. You just need to put the values and get the answer. You have an idea how these expressions are derived, how the energy became h cross pi square by h cross square, or the formula was saying h square by 8 ml square, nx square plus ny square plus nz square.
Yes, sir.
Okay, so then it's good.
It is 1.07 into 10 power minus 32 joules.
Yes, so the expression for energy of electron in a three-dimensional box is h square by 8 ml square nx square plus ny square plus nz square. So h is 6.6 into 10 to the power minus 34 joule into second. M is mass of electron 9.1 into 10 to the power minus 31 kg, and L is, what will be the value of L?
M is 9.1. Sorry, L 1 centimeter.
Yes, it is 1 centimeter, that is 10 to the power minus 2 meters. So if you put those values,
Minus 2 meters.
E will be 6.6 into 10 to the power minus 34 square into 18, because n square plus n square plus n square is given as 18. Then 8 into m is 9.1 into 10 to the power minus 31. Then n square 10 to the power minus 2 square. It will be 1.07 into 10 to the power minus 32 joule. So the correct option will be 1.07 into 10 to the power minus 32 joule. Is this clear to you?
Yes, sir.
Okay, so we will quickly move to the next question, which is the last question of today's lesson. The question says, in a metal of dimension 1 centimeter into 1 centimeter into 1 centimeter, the lowest energy of the free electron
PPT.
has a,
PPT not.
sorry,
PPT not visible. PPT not visible.
okay, now
Yeah.
visible?
Okay, sir. Yes, sir.
Okay, so question says, in a metal of dimension 1 centimeter cross 1 centimeter cross 1 centimeter, the lowest energy of the free electron has a wavelength of option A 0.5 centimeter, option B 1.1 centimeter, option C 3.3 centimeter, option D 4.4 centimeter. Basically, here we need to find out the wavelength. So, since the dimension is given and the lowest energy state, so for lowest energy state, what will be the value of Nx, Ny, Nz?
One.
Yes, so Nx will be 1, Ny will be 1, Nz will be 1. So we can calculate E111 will be h cross square Nx square plus Ny square plus Nz square divided by 8 ml square, and this energy, the relation between energy and momentum is given by p square is equals to 2me, is not it? So p will be
Yes.
2me root over, and lambda will be h by p. So can you calculate and tell me what will be the correct answer? From these values, you can easily calculate, because m, you know, m is the mass of electron, L is 1 centimeter. This is mass of electron. This h is also given. So if you once you put all these values, you can easily calculate E. Then from that value of E, you can calculate P, that is momentum. And then from the value of momentum, you can calculate lambda, that is h by p. So the value of E will be H plus square into 3 divided by 8 ml square, because nx equals to 1, sigma equals to 1, and z equals to 1. Will be 6.6 into 10 to the power minus 34 into 3 by 8 into 9.1 into 10 to the power minus 31 into 10 to the power minus 4. It will be 1.79 into 10 to the power minus 33.
Sir, is it 1.15 for 10 power minus 2?
Yes, it is 1.1
Yes, it is
centimeter.
1. Yeah.
So again, P is 2me root over. So 2 into 9.1 into 10 to the power minus 31 into 1.79 into 10 to the power minus 33 root over, which is 5.7 into 10 to the power minus 32 kg into meter per second. And then lambda is h by p. It is 6.6 into 10 to the power minus 34 divided by 5.7 into 10 to the power minus 32 meters. That is 1.1 centimeter. So the correct option will be option C. Sorry, option B. So this is clear to you?
Yes, sir.
Okay, so with this, we will stop our today's interaction session. So in the next interaction session, we will solve a
So
few problems. Yes,
problems answer. Which topic, sir?
we will solve problems on the topics of band theory of solids. How the solids are classified into conductors, insulators, and semiconductors. How the band appears in the solids. How there is forbidden energy gap. So all these concepts we will be covering, and we'll be solving a few more problems related to those topics.
Okay.